Good afternoon, students. So today we discuss equations of motion. So very important topic for 5 marks, either theory or for problem. Right? So here if they ask for the derivation, first we need or we write explanation. So this is compulsory for all the long answers. For 5 marks theory, first we need to write the explanation of the derivation, next diagram, and next proper steps. So if we are deriving the relation without diagram, so we get 0 marks, right? So each and every these three are very important: explanation, diagram, and proper mathematical steps. If you written only the proper mathematical steps, you get only 2. That is with improper diagram. Then only you get the 2 marks. Otherwise, you will get 0 marks. Right? So first we need to concentration on explanation. Right? So we have 3 equations of motion. So for 5 marks, it is very important. Right? So for the first, consider an object, right? So I am considering here one object. So considering an object moving in a uniform acceleration with initial velocity u, right? So I consider one object which is moving in a uniform acceleration. Its initial velocity u, moving with initial velocity, that is u, right? So after certain time t, right? As this is moving, so after certain time t, it covers some distance, right? So that velocity is v. So calling this velocity as final velocity, right? So as the object is moving with certain velocity in a uniform acceleration and it takes certain time, then here the position is the initial position calling x naught, and here is the final position calling x. So in this time t, it covers the displacement, that is this distance, right? So x is equals to x minus x naught, right? Calling this one as x1, here this one as x1, right? So x1 minus x0. So where x is the displacement, right? So this is the consideration. So here we considered initial velocity, uniform acceleration, and final velocity. It takes time t to cover this distance, that is x, right? So now we need to convert this explanation in the graphical method. So for that we need to plot the graph, right? So by plotting Vt graph. In the question itself they mentioned derive the equation of the motion by using graphical method. So for that we need to convert this in the form of graph, right? So here what we consider moving with initial velocity. So this is the velocity along y-axis, right? So some initial velocity means I will take here the point A. Already it has some velocity. If it is at rest means I will take from origin, right? So here the object which is moving with initial velocity, so I taken that point as A, right? So it covers certain distance or displacement. So for the time t, so along x-axis I will take this time as b. So calling here is O, right? So moving with uniform acceleration, then the curve is a straight line. So at the point B, here is the final velocity. So here we get the straight line, right? So then the graph AB, the line gives AB is the displacement of the object traveling from initial position to the final position, right? So now I will write the explanation here. So this is just for the understanding purpose, right? So start from consider an object is moving in a uniform acceleration, that is A, uniform acceleration A with initial velocity u. So after certain time, it covers the displacement, that is x, with final velocity is v. So here time v. So all the four variables we are explained here, right? So now we need to derive the relation between these four variables. So the first relation is v is equals to u plus at, right? So from the velocity time graph, that is the significance of the velocity time graph, what it says means slope of the curve AB gives the acceleration, right? So this one is the first significance. So VT graph, if we plot the slope, then that slope gives what? Acceleration, right? So now from 0 to A, its velocity, what we taken, that one as the initial velocity u, right? So here at point B is the final velocity, right? So this distance is v, right? So if we plot the slope, that is by drawing the triangle. So here it is C, here D. This time is T, right? So then this total distance BD is what? B. So we need BC. So BC distance is V minus U, right? So again here acceleration is equals to slope, right? So we know slope is tan theta. So if we plot the theta here, then tan theta is equals to opposite side by adjacent side, right? So acceleration A is equals to, so slope is what? Opposite side, that is BC divided by the adjacent side is what? AC, right? So here AC is parallel to OD. That means the distance from A to C is what? T. Then BC is V minus U, right? So A is equals to V minus U. So AC is T, right? So now cross multiply here. AT is equals to V minus U. So this can be written as V is equals to U plus AT. So this is the first equation, that is first law of, that is equation of motion. So this one is the first equation of motion, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken, right? So if they ask for only to derive this, we need to write all these things, right? So explanation for the corresponding diagram. Next, these are the mathematical steps, right? So next, second equation. So for the same diagram and same explanation, right? So the second significance of VT graph is area under the curve gives the displacement. So area under the curve gives what? Displacement, right? So displacement is equals to area. So this is the curve, right? So we need this area. So area under the curve, that is area O, A, B, C, D, right? So this is divided into two. One is triangle and rectangle, right? So that is area of triangle ABC plus area of rectangle ACDO, right? So here displacement we taken that one as x, right? So x is equals to, so area of the triangle is half into, so base is AC, right? So AC into height is BC, right? So plus area of the rectangle AO, length, that is breadth into length, that is OD. Right? So displacement x is equals to 1 by 2. So here AC, that is time t, into BC is what? B minus U. B minus U. Right? So plus AO is U into OD is what? T. Right? So again from equation 1, that is B is equals to U plus AT, right? So from this we can write B minus U is equals to A into T, right? So now we need to substitute here B minus U. So in place of B minus U, we are going to substitute AT, right? So x is equals to 1 by 2 into T into B minus U. In place of B minus U, that is AT plus UT, right? So then the final expression becomes x is equals to, first I will write UT plus 1 by 2 AT into T, that is T into T, T square. So half A T square. So this is the second equation of motion. So this is very important. Several times they ask only this one. So for the same equation, we need to write the same explanation and also same diagram, right? So this one is the second equation of motion, right? So next and the last, keep this one as is, that is area under the curve AB gives displacement, right? So displacement is equals to area of O, A, B, C and D. Right? So now just rearrange here. So here multiply this term, x is equals to 1 by 2 t into v, that is vt. So 1 by 2 t plus into minus minus. So here we get 1 by 2 u into t plus ut, right? So here we have the two same terms ut and ut. So here 1 and here minus of. So 1 minus of, again we get x is equals to 1 by 2 vt plus 1 by 2 ut. Right? So that is by taking LCM ut minus 1 by 2 ut. Right? So in this ut, if we take common 1 minus 1 by 2. Right? So 2 minus 1 is 1 into ut by 2. So again we get ut by 2. Right? So from this we can write v plus u divided by 2 into t. So x is equals to v plus u divided by 2 into t. Right? So I will continue here. X is equals to v plus u divided by 2 into t. Right? So again from the first equation, so if you observe here v minus u, right? So we need t, that is a, that is equals to t. So in place of t, we are going to substitute v minus u by a, right? So in place of t, we are going to substitute v minus u divided by a, right? So now cross multiply these terms. 2ax is equals to v plus u into v minus u, right? So this is in the form of a plus b into a minus b. So this can we write 2ax is equals to v square minus u square, right? So the final expression v square minus u square is equals to 2ax. So this one is the third relation, right? From 1, equation 1, calling this 1, right? So there is another method to find this relation by using the average velocity, right? So either anyone you can write. Right. So these are the three equations of motion. So very important while solving problems also. So the second method to find this relation is by using the average velocity, right? So we know displacement is equals to average velocity into time, right? So velocity is equals to displacement by time. So this one is the second method. Any one of the method you can write in the examination, right? So here again displacement we taken as x, right? So average velocity from this graph. So here we have u and here we have v. So for that average we can take v plus u divided by 2 because we have in two velocities u and v. Then average velocity becomes v plus u by 2 into time t. So again v plus u by 2 into from the first equation v minus u by a, right? So 2ax is equals to v square minus u square, right? So this is the second method, right? So these equations of motion we derived. So all these equations of motion is applicable for horizontal motion. That is, either the object is moving along positive x-axis or along negative x-axis. Right. So one more concept, that is, we write here equations of motion, that is horizontal. Right. So first equation, b is equals to u plus at. Next, x is equals to ut plus half at square. Next, b square minus u square is equals to 2ax. So these are the equations of motions which are applicable only for the horizontal motion. Right. So one more topic, that is vertical motion. So what is vertical motion? The object which is traveling in y direction, that means y axis, right? So an object moving under the influence of gravity. So that type of motion we call as vertical motion. So in vertical motion we have two types, right? So one is upward motion and second one is downward motion, right? So we have the relation v is equals to u plus at, x is equals to ut plus half at square, and v square minus u square is equals to 2a. So these are applicable only in the horizontal motion, that is along x-axis, right? So here we are going to discuss those equations of motion in upward motion and downward motion. So if we consider for the upward motion, so this one is the ground, right? So an object is throwing vertically upward. So either it may be ball or any object. So if this object is going upward means it has some initial velocity. So if we apply any velocity means that's why it is going in the upward direction. So otherwise it will be at the rest, right? So then it reaches the some height. Then that one displacement we taken as h. Here displacement is taken as h, that is height. So somewhere here the velocity is v. So u is the initial velocity and v is the final velocity. So this is for the upward motion, right? So it takes some time t to reach from this point to this point, right? So to travel height h, it takes time t with initial velocity u and final velocity v. Then what these relations changes to? So here as says it is moving in the influence of gravity, right? So the gravity direction here replacing acceleration by acceleration due to gravity, right? So what is acceleration due to gravity? It is denoted by g. So what is acceleration due to gravity? Any object, that is motion of an object influenced by only the acceleration, that is only by the gravity. So it gains the acceleration by the gravity. So that type of acceleration we call as acceleration due to gravity, right? So in the coordinate axis, that is from AT graph, right? So in the upward direction always we taken A as positive, in the downward direction always A taken as negative. So this one is in the coordinate graph, right? So but the acceleration due to gravity is always towards the center of earth, right? So acceleration is a vector quantity. It has both magnitude and direction. So its direction is always towards the center of earth. That means g is positive only in downward direction, but acceleration is negative, but g is positive. So for the object which are traveling from top to bottom, that is from the certain height to the ground, then the G value is positive. So if the object is moving vertically upward direction, then G is negative. That is opposite to the direction of the gravity, right? So G is negative and its value is always constant, that is 9.8 meter per second square, right? So in the upward direction, G is negative, right? So this is about the acceleration. So now we need to replace wherever A just by replacing the term G, right? So now if we return here the equations of motion for the upward motion, then V is equals to U. So in place of A, we are going to write minus gt, because for the upward motion G is negative, right? So V is equals to U minus gt. Next, in place of x, we are replacing by h, that is height. H is equals to ut minus half gt square, right? So next, v square minus u square, that is equals to minus 2gh, right? So these are the equations of motion for the vertically upward motion, that is vertically upward motion, right? So next, second case, free fall or first downward motion, right? So here we have the ground. So from the certain height we have placed the object, right? So now this object is moving with initial velocity u and reaches the ground here with a velocity v, right? So this is along straight line. So it takes time t. So as now says, acceleration due to gravity g is positive in downward direction. That is object moving from top to bottom, right? So now if we replace the equations of motion for the vertically downward motion, then v is equals to u plus gt, then h is equals to ut plus half gt square. Next, v square minus u square is equals to 2gh, right? So every case g is constant, the g value is 9.8 meter per second square. So for simplification purpose, we can take this one as round of 10 meter per second square, right? So these are the two cases. So here one more special case is there. That one, that is free fall. So during free fall, the object is traveling from top to bottom, that is from the upward to downward, that is from higher to lower, that is in the downward motion. So if we consider an object here, it will reach the ground here. So this one is a special case. So here its initial velocity u is 0 for the free fall, right? So wherever they mention free fall, then its initial velocity is always 0. So it gains the velocity v by the acceleration due to gravity, right? So it takes some time t. Then equations of motions become here. Wherever u, we need to substitute 0, right? So then v is equals to g into t. Next, second equation becomes h is equals to half gt square, right? So next, third equation becomes v square is equals to 2gh. So from these three equations, from this equation we can find the time taken to reach the ground when a freely falling object it takes how much time? So that we are going to calculate by using this relation. So from this we get t is equals to square root under 2h divided by g. So we need to remember this part. So next, at what velocity the object will reach the ground? So that is from this relation, right? V is equals to under square root of 2gh, right? So these are the two important relations under free fall. So in free fall, always its initial velocity u is 0, right? So these are the equations of motion in upward direction, downward direction, and along horizontal. So one more special case is free fall case, right? So in free fall case, we are going to calculate the time. So time is depends only on the height, right? So we have four variables, that is velocity, initial velocity u, final velocity v, and time, then height, right? So here if we drop any object of any mass, right? So if I drop the ball of 0.1 kg and a stone of some 3 kg from the same height, right? So I am dropping the ball and here stone from the same height, right? Then which object will reach the ground faster? So I am dropping one, that is ball which has less mass and stone which has greater mass from the same height, right? So which will reach the ground in the same time. So for that, time of an object during its free fall is directly relates with the height, because 2 is constant and g is constant. So only the variable is height, right? So t is directly proportional to h. So in some case, if they relate means here is the ground. So here ball, that is similar ball. So height is some 3 meter. So it takes time t1 is equals to 2 seconds, right? So similar ball will be dropped from another height, that is about some 6 meter. Then how much time it will take to reach the ground? So for this we need to relate these two relations, right? So as we know, time taken by an object in a free fall is directly relates with the square root of height, right? So here we have one relation t1, then h1. So if we return here, t2 is proportional to root h2. We need t2, right? So now we need to divide these two equations. We get t1 by t2, that is equals to under root h1 by h2, right? So we know height square root of, so h1 is 3, h2 is 6. So we get under root 1 by 2. So we need to find t2, right? So t2 is equals to square root of t1. So square root of 1 is 1. So this becomes 1 by root 2. So if we shift the t2 to RHS, then t2 is equals to root 2 into t1, right? So root 2 into time for the first object is 2 seconds, then 2 into root 2 value is 1.41, right? So it takes 2.82 seconds. So if the object takes 2 seconds to reach here, then t2 is 2.82 seconds. Like this we get the problems in competitive exams, right? So for that, here t is proportional to h. In the similar manner, here also velocity, final velocity of the object is relates with the square root of h, because 2 is constant, g is constant, then v is directly proportional to h. Right? So here this object having some velocity. Sorry, here we have free fall, right? So it is dropping from 3 meter. We don't know how much time it takes to reach the ground. We need to find the velocity here. For that, V1. So in the same way, we know the height 6 meter. Then here we need to find V2. So if they given V1, that is equals to some 3 meter per second square. Then what about V2? So by using the same relation, V1 is proportional to square root of H1, V2 is proportional to square root of H2, right? So V1 by V2 is equals to under root of H1 by H2, right? So this is 3 divided by 6, again it becomes 1 by root 2. So they given V1, we need to find V2. V2 is equals to square root 2 into V1, right? So we get 1.41 into 3, that is 4.23 meter per second. That means we are relating one object with the another object to find the velocity of the particular object. So by using these relations, right? So this is only in the case of free fall, right? So in horizontal motion, if the given one velocity, we can't write v is directly proportional to u, or v is directly proportional to a, or v is directly proportional to t, right? So if they mention when time taken is 0, then x is proportional to a or x is proportional, here total becomes 0, because t is 0, then whole equation becomes 0. So by observing the conditions, we can relate like this, right? So in the next class, we will solve the problems which they ask in exam. So these type of problems will ask in competitive exams. So basic simple problems they will ask in board exam, right? Thank you.